Okay, so again, what have we been up to this unit, right? We started this unit by looking at cubics specifically, right? So the unit before this, we did quadratics. That's, polynomials of degree 2. We started this unit with polynomials of degree 3, cubics, right? And we learned their parent function. And we also did their transformations and stuff like that, graphed them, okay? And then we kind of expanded even more, though. So we're kind of covering 2 types of graphs, right? We then just went into like general polynomials. So any kind of polynomial. We talked about how to sketch the graph of polynomials. And then recently we talked about how to add, subtract, and multiply polynomials. And we also did factoring too. Okay? So I wanted to pick up a few more places where we need to know how to factor. Okay? And then we're going to talk about dividing polynomials too. Okay? We're going to do long division today, which I know it's everyone's favorite, way to divide. And then tomorrow we'll look at synthetic division. Okay? So again, you can kind of think here, we're just kind of continuing in this idea of factoring polynomials, how to take a polynomial that's in standard form and how to break it down into its factors. Okay? How to break it down into its factors. Okay, and again, you can see the benefit, like in the warm-up here, about why it's important that we can factor a polynomial, because if we want to solve a polynomial equation, factoring is going to be important there, so we can use that zero product property. All right, so. So we'll be factoring again and dividing polynomials using long division. Okay, can I get it all to fit there? Yeah. Okay. Let's log into the Wi-Fi here real quick. Or slow. Okay. So let's take a look at a problem here. Again, just going to pick up some more like special integration techniques, I guess, or not special integration techniques, special factoring techniques. Okay, special factoring techniques here. Okay. So, let's go back through our different skills that we have, all right, here to factor, right? So first of all, does GCF work here? Is there a greatest common factor that we can take out of these two terms? Is there something in common to both terms that we can take out from both terms? Both divide by 4? I don't think 81 divides by 4. Nope. And not an 8 either. Nope. 16 divides by 8, but 81 does not divide by 8. Evenly. So, is there anything we can take out? There isn't one. Yeah, there isn't one. Okay? There is not a way to factor this using GCF. Okay? Let's see here. Well, it's definitely not a quadratic, right? Because we have degree what here? What is this degree? 4. Okay, so it's not quadratic, so we can't factor it like a quadratic. So let's see here. What about, well, we could group with only 2 terms. Normally with grouping, we do need an even number of terms here, but we can't just like group these and group that. That wouldn't quite work, right? So, okay, right. So what this is actually a difference of squares. Okay, difference of squares. Okay, so Julian did recognize here that 16 and 81 are perfect squares. X to the 4th is also a perfect square, though. Okay, x to the 4th is a perfect square of what? What squared gives you x to the 4th? X squared does. That's right. Okay, so if you recall here, we're going to use this formula to help us with the difference of squares. I put it up here. Right, I'm going to rewrite it up here on the notes, though, for us. So the difference of squares. Okay,
Again, if you have a squared minus b squared, so again, difference of squares, it's not a special, it's not some like magic name for it, right? It's a difference. We're subtracting, and we're subtracting squares. That's why it's called a difference of squares. There's nothing, weird about that. All right, what does it factor to be? A minus b times a plus b. Okay? So in this case, it's going to be important for us to determine what is our a, what is our b, right? Because in a difference of squares, you have your a, and it's being squared, and you subtract your b that's being squared, right? And what does it factor to be? That a minus the b, and then times the a plus the b. So let's look right here at this, okay? Let's maybe do the easier one here. This 81, okay? What squared gives us 81? 9. So in other words, I can rewrite this 81 as 9 squared. Right? Okay? Now, for this one over here, it's a little bit trickier because we have numbers and letters here, numbers and variables. Let's just focus on the numbers first. What squared gives us 16? 4, right? And then, again, I think we already answered this, right? But what squared gives us x to the 4th? X squared. Okay? So can you see the difference of squares now? It maybe wasn't easy to see here, but now when we look, you see, oh, wait, 4x squared gives us this. 9 squared gives us this. So there's our difference of squares, okay? And that makes then our a is the 4x squared. And our b is what? What number? Yeah, 9 is associated with the b there. Okay? That's right. Okay? So there's our a being squared. There's our b being squared. All right? So now we can factor this thing. And again, how does the difference of squares factor? How does the difference of squares factor? A minus b, a plus b. Bless you, bless you. So a, 4x squared, minus b, 9. Okay, there's our a minus b. Okay, and then we'll multiply times a plus b. Okay, so then what will be in this factor? What's going to go here? What's our a? 4x squared. And what's our b? 9. So there you go. Okay. So again, we took something that at first glance, it didn't look quadratic, right? But we actually could factor it kind of like in a quadratic way. Okay? Not quadratic, but we factor it in a quadratic way because this looks quadratic, right? You got the a squared and b squared there. Okay? It does factor. Okay, now, there's another difference of squares here, isn't there? Our answer has a difference of squares in it, doesn't it? Yeah, it does, okay? So I'm going to further break this down. The 4x squared minus 9 is a difference of perfect squares, right? 4x squared is the same thing. So what squared gives us 4x squared? Well, let's focus on the 4. What squared gives us 4? What number when you square it gives you 4? 2. What number when you square it gives you x squared? X. So in other words, 4x squared is the same thing as 2x quantity squared. What number when you square it gives you 9? 3. So you see we have another difference of squares show up in here. Okay. Now, there is no formula for a sum of squares. 4x squared is a perfect square, 9 is a perfect square, but there is no formula for a sum of squares. We can't break that up, okay? You can try it, but it just won't work. So we're just going to have to leave that one for now. Okay, if you don't believe me, you can find the discriminant of this, and you'll see that we get 2 non-real solutions. All right, anyway, so let's factor this one more time. Again, our a in this case now is 2x. Let's finish this problem first and I'll let you go. Okay. So 2x quantity squared minus 3 squared. All right, again, it's a squared minus b squared. So there's our a squared minus our b squared, and we'll just factor it to a minus b times a plus b. So again, it's going to be our a, 2x, minus our b of 3 times then our a of 2x plus our b of 3. Okay? And then we still have that 4x squared minus 9, or 4x squared plus 9, I should say. And there is our fully factored problem there. Okay? So keep an eye out for those kind of problems there. Okay? Keep an eye out for those kind of problems there. Let me give you guys one here to try. So let me have you guys try one here. So here you guys try, and again, just factor. So again, it's going to be a difference of squares here. Let me make one up. Let's do 9x squared minus 25. Okay, so I'll leave that up there so you can see. We go ahead and try 9x squared minus 25. All right. Now this one is quadratic, so you could just, put a middle term of 0x in there, and then use our, normal quadratic rules here. Or you can try using the difference of squares formula that we've got here on the board. But give that one a try. Okay. See what you can come up with there. And then AJ, if you want to go right now, that's fine. Thank you for waiting. Okay, I'll help you out a little bit here. I'll give you that for the first step. And again, we're just factoring. Just factoring here. Recognize that this is a perfect square and this is a perfect square. Okay, so then we show what is a perfect square of. It's a perfect square of 3x, right? 3x quantity squared gives you this, and then 5 squared gives you that, right? So we show this. That makes this. Okay, if you look up here, difference of squares, right? That makes this the a, and that is b. And so then it will factor to be exactly this: a minus b, a plus b. Okay. Yes, exactly. Yes, yes. All one thing. So no squared. And no squared there. And then you're right. Okay? Because Gio, if you look here, in the original form, you have a and it's being squared. But then when you go to factor it, it's just a, no square. See what I'm saying? The difference there? So that the a squared is this. The a by itself is 3x, and then it is squared. So 3x is your a. Just 3x, no square. Okay? Yep, good. Okay, good. Okay? Questions on any of that? Oh, we're not done. Okay, but there's our answer. There's our answer right here. Okay? All right. All right. We'll do this. So that's our difference of squares formula. Okay? I will not give this formula to you. I will not be giving this formula to you. Okay? So if you want to memorize it, you can. But remember, well, this one maybe is harder to do, right, without knowing the formula. But this one is pretty doable without knowing the a squared minus b squared equals a minus b times a plus b. You could just factor this like a quadratic, put in a 0x there. I think you could be okay there. Okay? So I won't be giving you this as a formula. But what I will give you are these next two. Okay? So that's, again, difference of squares. Now, the two other formulas that I will give you here is a sum of cubes, and we also have a difference of two cubics. Okay? A sum of cubes, and a difference of cubes. Okay, so again, difference of squares, I'm not going to give that to you, but I will give you these formulas, okay? So difference of squares, what were we doing? We subtracted two perfect squares. So for a sum of cubes, we're going to be adding two perfect cubes. Okay? So there's a cubed plus b cubed, and that will always factor to be a plus b times a squared minus ab plus b squared. A plus b times a squared minus ab plus b squared. And ab next to each other just means you're going to multiply a times b there. Okay? For the difference of cubes, a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Okay? So those are the two, also to the two special cubic factorizations that we're going to do. And don't worry, we're not going to, do anything higher than that. Okay, so that's it. Cubes, difference of cubes, sum of cubes. That's the highest we're going to go. Okay. But the idea, the way we do it is very similar to how we just did the difference of squares. All you need to do is recognize that you have a sum of cubes, and then to just, plug the numbers into the formula here. Just identify the a and b, and then plug the numbers into the formula. So let me just show you what I mean by that. So I'll do an example of each. Okay, so let me do x cubed minus 27. Okay, is x cubed a perfect cube?
No.
Is x cubed a perfect cube?
No.
Yes, it's a perfect cube of what? What cube gives you x cubed? Just x, right? Just x. Yeah, not a trick question. When you cube x, you get x cubed, right? Okay. Is 27 a perfect cube? Or in other words, what times what times what gives you 27? 3 times 3 times 3. 3 cubed is 27. Right, so I can rewrite this then so we can recognize, this is a difference. Oh, I put it under, here, let me just put a plus sign. There, we'll make a plus. I'll do the sum under the sum one. That makes more sense for organization, right? All right, make it a sum. So that's a perfect cube. It's a perfect cube of x, so it's just x cubed, right? Plus, and then we said that 27 was what cubed? 3 cubed. 3 times 3 times 3. Yeah. Okay. So that makes x like what up here? What letter? X is like our a. And that makes our 3 like our b then, right? So then what will x cubed plus 27 factor to be? It factors to be a plus b. So in our case, a is x plus the b of 3. And then a squared, which means what will I write? If a is x, then a squared will be what? X squared. Okay, minus ab. They're written next to each other. So AB is going to be minus 3x. I'm going to put it in the right order. You could write x3 if you want to, but we normally put our numbers in front of our variables and stuff, right? And then plus at the end there, what's b squared going to be in our case? 9. Yeah, b and then squared is 9. And so there it is. Okay. Now you might be thinking to yourself, oh, Mr. Whitmire, that's a quadratic. I don't have to factor that, do I? And the answer is, for difference of cubes and sum of cubes, no. This left over, even though it is quadratic, and we know that quadratics sometimes factor, this quadratic will never factor. Okay, this will never factor. Okay, it will never factor. And so this is our final answer right here. That's as far as we can go. Okay. You can try using the quadratic formula there if you want to figure out what the zeros would be. But as far as factoring, this thing's not going to factor any further. And we're just worried about factoring right now. Okay. Let's try another one. Let's do 27 y to the third minus 64. Okay. Is 27y to the third a perfect cube? It is. It's a perfect cube of what? What cube gives us 27y to the third? 3y, right. We got to include the 3 and the y there, quantity cubed. Is 64 a perfect cube? Yeah. What times what times what? 4. Yes, 4 times 4 times 4. Okay. That's A, and that's B again. Okay. Now for the difference of cubes, right, you can see there's a lot of similarities, right? You have the A, the B, you have the A squared, the AB, and the B squared. It's just the signs that change, right? We have a minus for the A minus for the A and the B, and they have a plus between the A squared and the AB. But there's always that plus B squared at the end. All right, so 3y minus 4, right, for the A minus B, times A squared. What's our A squared going to be here? Our A is 3y, so A squared is going to be what? If A is 3y, what's A squared going to be? 9y squared. Yeah. Plus A times B, so 3y times 4, 12y. And then B squared, 16. Okay, there it is. And just like I said, for the sum of cubes, you have a quadratic left over, right? That quadratic will never factor. Okay, it will never factor. So the quadratic that results from the sum or difference of cubes, you don't have to worry about factoring it. All right, and I got one more thing I'm going to show you here, which is long division. Long division. And I saved the best for last. Okay, so let me see here. Yeah, I'll start here and then I'll show you some problems. All right, so you guys remember how to do long division? You know what I'm talking about? If I want to take 472 and divide it by 7 and I don't have a calculator around, right? How do we do that? And remember you used to do something like this. Right? Is that ringing a bell? Yes? You've done that before in the past? All right, it was great times. Lots of fun. Used to be good at it? Oh, okay. Okay. Yes, I remember learning this in 4th grade. I was sick the first day that we learned this, and I felt like I was behind for a week after that because it just was so weird. So... Yeah, I know. Common Core, I know you guys did all sorts here, draw some X's and then, break it down into tens and hundreds and I don't even know, repeated subtraction. Well, whatever. All right. So anyway, long division is an algorithm, okay? It's kind of like a program that you do by hand, all right, that allows us to divide two numbers, all right? So, and again, you may have learned it slightly different ways, but we'll just go through it here. So what you want to do here is look at your number that you're dividing by. We're dividing by 7, okay? And you want to look at the very first digit here, 4, okay? Does 7 divide into 4? any times? No, the answer is no, right? 7 is not divided into 4 at all, okay, because 4 is too small. So then we consider the 4 and the 7 together. Okay, right, so we want to say 6, okay? Why 6? Because 6 times 7 is going to give us 42. We wouldn't want to say 8 here because 8 times 7 is going to be too big, 48. We don't have 48, we only have 47. So the biggest that we can make our number here without going over the 47 is going to be 42 by using a 6. Okay, so 6 times 7, 42. Right, so we do the 6 times the 7, we get this number right here. Okay, and then we subtract, right? So 47 take away 42, what's that leave? 50, well, so a 5, right? And then we're going to bring down the 2. Because again, 7 does not go into 5 anymore, so we have to bring down the 2. Okay, right. And so we ask ourselves, okay, we want to get as close as we can to 52 without going over. It's kind of like the Price is Right, right? So don't bet a penny though, all right? So bless you. So what times 7 gets us close to 52? 7, right. We get 49. And we have a remainder of 3, right? There's no more things to bring down. Now, if you wanted to, this is how you can find like decimals and stuff like that. So if you guys, if you were doing this and you want to find decimals and stuff like that, you could now put a decimal point in, plug in a 0, and continue the algorithm, dot, dot, dot. You continue on. You just keep adding zeros, dropping things down. You'd add a decimal point here too as well. Okay. We're not going to do that though. We're just going to worry about what our remainder is. So our remainder is 3. Whoops, why did I put like a cube? R3, remainder 3. You guys remember, did you do stuff like this before too with R3? Yeah. Used to hate it. Okay, so 67, and the remainder is 3. That 3, right, it's still left over. It's not divided by 7 yet, so we're going to say 67 and 3/7 is another way you could write that. So you could say 67 remainder 3, but you could also say 67 and 3/7, right? That's the same thing. Okay? 67 and 3/7. If you don't believe me, let me show you. Okay, so take a look here. If I take 472, excuse me, 472 divided by 7, okay, look, there's our 67. And then we have this decimal piece here, and watch, what's 3/7? There's our decimal piece. 4, 2, 8, 5, 7, 1, 4, 2, 8, 6, okay? So this remainder, if you put it over top of what you're dividing by, that's like the fraction right there, 67 and 3/7. Okay? That's long division. You can also do it with polynomials. Like, Mr. Wid, polynomial stuff is too easy. Can we make it harder? Yes. Yes, we can. Yes, we can. Yes, we can. That wasn't what you were asking? Gosh, well, why did I just say that then? I don't know. So, sometimes, right, when we come across something, we want to factor it. Like, well, for example, this, right? This polynomial, right? Is there a GCF here in this polynomial? Nope. Is it quadratic? No, so we can't, it's not because we have the cube there. So it's not quadratic, so we can't factor like a quadratic. Could we factor by grouping here? You could group, but it's not going to work, right? I mean, if we group the first two together, we'll be able to take out an x squared, but we'll have an x plus 5 left over. There's nothing I can take out of this group, so I won't have an x plus 5 left over. So factor by grouping fails. Yet, we're going to see here, actually, no, never mind, x minus 2 doesn't work. But sometimes we can still try and divide other stuff out, right? So sometimes it will still factor, but we just can't use one of our techniques. So division is a way to check that too, though. Anyway. All right, let me just show you long division here then. So what are we dividing by? The x minus 2. So what goes in here? The thing that we are dividing. Yeah, so the x cubed plus 5x squared minus 7x plus 2. Okay? And then x minus 2 goes in front there because that's what we're dividing by. Okay? So far, so good. Not that awful. We can set it up at least, right? Okay. Now, again, think back to that long division problem we were just doing. When we go to do the algorithm here, right, we took this, And we asked, we took that 7, we asked how many times, right, or what times 7 will get us close to that 47, right? What times 7 will get us close to that 47? So, same thing here. We're going to ask what times the x will get us close to x cubed. So, what times x will get us x cubed? What can we multiply x by to get x cubed? X what? X squared. Exactly right. We're going to put an x squared up here. Okay? X squared times x, x to the third. X squared, what else are we going to multiply the x squared with? Not just the x, but also the, what else is there? The 2, minus 2. So it'll be minus 2x squared. Okay? And we're going to subtract this quantity. Okay? We're going to subtract that quantity. You can see why we did polynomial addition, subtraction, okay, multiplication. It's not too much. I disagree, but I hear what you're saying though. It is a lot. It's a lot. It's a lot, but it's not too much. Okay? So, x squared times x, x cubed, x squared times minus 2x squared. Okay? Now we have this minus sign in front of parentheses, so I'm going to change it to add the opposites. Okay? It makes it a little bit easier to do the math here. What happens to our x cubeds? They cancel. Okay? What about our x squared terms here? What do we get? 7x squared. Okay? And then we bring down the next term, right? Minus 7x. So bring down the minus 7x. Okay? Same question again. So any questions up to this point? I lose anybody up at this point? Besides just you look at that and it's too much, you think. All right? I mean, any confusions? So now we're going to look, so now we're going to look for a number. What times x will give us 7x squared? What times x will give us 7x squared? So a 7x, exactly right. 7 times a 1 will give us 7. X times x will give us the x squared. So so 7x squared is what we're going to get there. Again, we're subtracting. 7x times minus 2, minus 14x. Okay, so again, the 7x distributes to the x and the minus 2 there. Okay. Now, instead of subtracting, I'll change it to add the opposites. So it'll be plus negative 7x squared plus 14x, like that. Okay. What happens to our 7x squareds? Cancel. What happens to our, so what about negative 7x plus 14x? What does that simplify to be? 7x. And then we bring down the 2. Almost done. Almost done. What times x will give us 7x? 7. Just a 7. 7 times x, 7x. 7 times minus 2, minus 14. And we'll subtract the quantity again. Okay. But again, because I don't like dealing with subtraction, especially when it's in front of parentheses, I'll make it plus the opposites. What happens to the 7s? They cancel. 2 plus 14, 16. Now, is there a number that I can multiply x by and get just a 16? No. This is therefore our what? Remainder. So remainder 16. So what is the final answer here? It's going to be x squared plus 7x plus 7. We could say remainder 16. But what does this really mean? We still have to divide 16 by the x minus 2, right? That 16 is left over. It still remains to be divided. So I'm going to add it on here at the end and say we still have to take that 16 and divide by x minus 2. And that is our final answer right there. Okay? The 16 remainder still has to be divided by x minus 2. Okay? to show you one more little thing here, okay? And then I'll give you guys I'll let you guys decide whether you want to get started on the assignment or you can watch me finish that second one. So I'll do a second example, okay? I at least want you to just follow through at least with the setup for this second example because it's a little different than this one, okay? If you want to actually see the solving part, I'll do it as well. Or if you feel ready, I'll let you start on the homework, okay? So we'll do that. All right, so I'll leave that up to you. All right? But for right now, I do want you to just follow along real quick with the setup for this next one. Okay? So one more setup here, and then I'll let you guys get started on the assignment. Okay. Okay? Another division. If you look at what we are dividing here, there's something missing. What's missing from this polynomial here? What's missing? We have a 3x to the fourth. We have a 5x cubed. Shh, listen up here. We have no x squared term in here. Okay? And that is not something we can ignore. We need to be able to recognize, ooh, we don't have an x squared term in here. Now you can say, Mr. Wade, we don't have an x to the fifth or an x to the sixth or an x to the seventh. True. But when you're missing a term between, so you have a term above it, you have a term below it, we need to do something when we're missing that x squared term here. Likewise here, we're missing what term here? An x in between, right? So again, if you're missing stuff, you know, like before, like x to the fifth, x to the sixth, that's okay. It's when we're missing terms in between, that's a problem. So how are we going to set this up? Well, I'll put in the 3x to the fourth here, minus 5x to the third. How many x squared terms do we have here? What quantity? What number quantity? 0. So we're going to put a 0x squared plus 4x minus 6. Okay? This is known as a placeholder. Okay? But we need it because otherwise it's going to mess up our algorithm, our little long division program here. Likewise, out front, when I write out x squared minus 5, I should really write it as x squared. How many x terms do we have from here? We have 0, so a plus 0x minus 5. Okay, so there's your setup, and then you just proceed as you did for the earlier one. All right, so at this point, if you want to get started on the homework, you're like, at this point, Mr. Wade, I can do this long division. Then I'll get you guys started on the homework. Okay, so for those of you that want to get started on the homework right now, you're feeling good about this, or even if you like, I can multitask, Mr. Wade, I'll start the homework, and then I'll, follow along while you're doing it. That's fine too. Okay. The homework's going to be from 3 sections because we kind of covered a variety of topics here. So in 6.4, which is page 228, I'm going to have you numbers 3 and 5. Okay. Then in 6.5, on page 238, I'm going to have you numbers 5, 6, and 12. And then on 7.1, page 252, I'll just have you do number 2. Okay. So there you go. So if you want to go ahead and get started on that, feel free. Otherwise, I'm going to finish this problem right here. So your choice. There are books in the back there. Some of you guys have books on your desk. You can pull it up on your Chromebooks or whatever. Your choice. But I'm going to finish this problem here real quick just so we can have something to, one more problem here to look at. Okay. So for those of you following along here, again, we're going to look for what times x squared will give us 3x to the fourth. So again, it's just our lead terms here. I don't really care about what this stuff down in here. I care about my lead term. So what times x squared will give us 3x to the fourth? 3x squared. So multiply there, you get 3x to the fourth. Okay? Distribute here. 3x squared times 0x is going to be 0x to the third. And then 3x squared times minus 5, minus 15x squared. Okay, and again, we'll just subtract that quantity. Okay. But again, I don't like subtracting when I'm dealing with, a polynomial here, so I'm going to change to add the opposites. Okay. What happened to our 3x to the fourth terms? They cancel, right? The lead term should always cancel when you're doing this long division here. These, well, it's negative 5 plus 0, so it's just going to be negative 5x to the third. And then 0 plus 15, 15x squared. And then bring down your 4x. All right, repeat, right? So what times x squared gives us a negative 5x cubed? Negative 5 what? X. Negative 5x times x squared will give us a negative 5x to the third. Negative 5x times 0, negative 5x squared. Negative 5x times negative 5, positive 25x. Okay? And then instead of subtracting, add the opposites. So make them all opposite there in the parentheses. 5x cubes cancel. 15 plus 5 is 20. Okay, and then 4 plus negative 25 is negative 21x. Bring down the minus 6. Okay, and then again, repeat. What times x squared gives us 20x squared? Okay, what times x squared gives us 20x squared? 20, yeah, it's 20. 20 times x squared is 20x squared. 20 times 0x is 0x. 20 times minus 5 is minus 100. And again, subtract. Okay, and again, instead of subtracting, add the opposites. So 20 and negative 20x squared cancels. Negative 21 and negative 0 becomes negative 21x. And then negative 6 plus 100 is 94. Okay. Now if you look here at this, can we multiply x squared by something to get a negative 21x? No. So we are done. This is our remainder. R. So r negative 21x plus 94. Or in other words, what we could really write this as is 3x squared minus 5x plus 20 plus negative 21x plus 94 all over x squared minus 5. Okay, there it is all written out. Okay. All right, so you got some factoring in here. 7-1 is where your long division is. So if you want to jump to that one and just practice that long division right there, okay? It's in that section. Okay, so if you want to do the long division one first, feel free. And then this one is, I think this one's like solving equations. It's like set equal to 0 and solve here. Okay. So 6-5 is like we did in the warm-up, and then 6-4 I think is also just more factoring, but I think I gave you some perfect cubes here. Sum of difference of cubes. Okay. So there's your 2.